Jim Dunshee. My poster is about my work with the motor vehicle emission simulator for from the EPA, and it's basically an evaluation of that with data collected in the Transportation Air Quality Lab. And what we're trying to do is see how the model stacks up to real-world data for a particular circumstance with light-duty diesel engines fueled by biodiesel. So this is kind of preliminary work in that we already have data collected with a light-duty engine for certain pollutants, particulates, total hydrocarbons, oxides of nitrogen, kind of the main criteria pollutants for the EPA. And now in this work I was basically trying to run the model and come up with a suitable baseline comparison for the model, basically trying to simulate what we did in the lab with the model. So I had to set up certain baseline conditions to kind of figure out what the model is using as its underlying emissions rates for certain operating conditions for a vehicle. So the model is based on kind of this power term, vehicle-specific power, assuming that your emissions rates change with kind of the power output of the car at different speeds that you're going. So that's what all these plots are based on. And for me, so I try to set up, try to find emission rates from the model for a single diesel passenger car, just fueled by diesel as the baseline, and then see what the model does for certain adjustments under certain conditions. I did a sensitivity analysis to see how the emission rates changed if you told it to run it with 10% biodiesel, 20% biodiesel, up to 100%. And I discovered it's in the technical literature, but I just basically verified that it makes these pretty simple linear adjustments. And then I examined what it does under different ambient conditions, different temperature and humidity conditions. And the primary thing it does with running exhaust actually is it just assumes that there's a certain amount of air conditioning usage at different temperature and humidity combinations. So you can kind of see on the plot here, there's 0% change up to a certain extent, and then the model assumes, based on heat index, that air conditioning is on to a certain percentage, and then when it's 100% on, it stops making adjustments. And then the only other adjustment it was making was for humidity sensitivity for oxides of nitrogen. So, kind of big picture, this is just telling me that at a certain point, I can use these emission rates under these conditions for comparison to our model before Move starts making adjustments based on these other conditions. Because our engine doesn't have air conditioning or anything, so basically. I hope that made sense.